Okay, we're going to talk a little bit about I'm going to talk about the natural logarithmic function. And I'm going to start with a definition. You've probably seen the function before, but we're going to start from the beginning and define the natural log this way with this integral. Okay, so that's going to be our definition starting point. Okay, so from that, we immediately see a few things. The derivative is just 1 over x using the second fundamental theorem. Okay, and also from the integral, we can see that the domain is x greater than 0, stated that way in the definition. The range is not so obvious, but we can have negative values all the way to negative infinity and positives all the way to plus infinity. This is a continuous function. The way it's set up, any value of x is allowable in the domain. It's increasing and 1 to 1. How do you know it's increasing? Well, because the derivative is 1 over x, and that's a positive quantity for x greater than 0, so it's an increasing function. It's concave downward, that's not so obvious, but if you take a second derivative, you'll see you get at minus 1 over x squared, which is negative for positive x, which means it's concave downward. So these things are somewhat, we follow from the derivative, a couple of these ideas here. It's 1 to 1. You can see that one because it's always increasing. These, okay, now we've got a couple other properties that come right out of the definition. Natural log of 1 is 0 because integral 1 to 1 is a 0. These couple properties are not so obvious. We'd have to take some time to prove them, 2, 3, and 4. But they are the familiar properties that you are aware of from your college algebra intro to natural log function. So they are not different here. They're the same. We'd have to spend a little bit of time developing these, but they're not that difficult to derive. Okay, here's the definition now of E. E would be the number, a number such that this integral equals a 1. That's by definition. That's what we're calling E. Okay. Now the derivative of the function is 1 over x, but if it's a function, natural log of a function of x, we need a chain rule. So you end up with this form, u prime over u. So here is u prime over u. And if you have absolute values, it turns out it's the same. The natural log of the absolute value of u is u prime over u also. So in general, when we integrate, we'll always assume coming backwards that we have this form here, the more general absolute value of x, absolute value of u, even if we don't need it, use it. Okay, now let's take a couple examples here. I want to get a couple of things done in this video besides just talking about the definition here. So let's jump right in here and get a derivative. F prime of x. Since it's not just x, it would have to be the derivative, which is a 4x over the 2x squared plus 1. That's it. Y prime. Well, we can jump right in and take the derivative of this quantity and divide it by itself. Or you could say, before you start, you could say this is 1/2 natural log of the x squared minus 4. Okay, and we're, of course, assuming that the appropriate values for this expression, x squared minus 4, appropriate domain values. But in any case, we'll have a derivative now. It would be 1/2. We'll have a 2x over an x squared minus 4. that, which is just an x over x squared minus 4. Okay, now keep in mind that this function, the domain for this function, we'd have to have x squared greater than or equal to 4. Actually greater than 4, because you can't have a natural log of 0. So this would be in here, we have x greater than 2 and x less than negative 2. So it's a kind of a strange looking function, but anyway, we're not worried about that right now too much. Okay, next one, natural log of the natural log of x. All right, this is an interesting one. We'll make this our last one, then we'll go to another video. Okay, so we got a natural log of the natural log. So to get the derivative started, y prime is the derivative of the inside here. Well, that's a 1 over x divided by the inside, which is natural log of x. So this would be 1 over x, natural log of x. That's an interesting form then. So again, if you look at this, you need the chain rule since it's a natural log. And then the function itself is a natural log, so its derivative is 1 over x. That's the u prime over u. And it reduces to that.